Hello dear students, let us see how to push a new node in the stack. So we are looking at a function called push function. It is very important first of all to know that how is this push function called or invoked from main function. So let's go to main and just check the call to push. Now here is main, which is menu driven main. The main has been written by using switch case where the options have been asked to the operator, what do you want to do? Do you want to push a value or pop a value or display or destroy the stack or exit? And out of that, first option is for push. From case 1 here, as you see, if the option given by the user is yes, user wants to push a new value, that is option 1, then we will ask the user to enter some integer to push, and the user will enter the value of his or her choice in a variable called x. Let's say x entered by the user is 10. So what that means is that the user is interested in pushing a new value 10 in the stack. And here is our topic. This is the call. This is the call to push function, and this has been done in main. Now, how is push called? You see, we are passing address of s and we are passing value of x. The value of x is 10. That means we want to push 10 in the stack s. But note, we have not called push by simply passing s and x. What we have done is we have passed the address of the stack, address of s. Now, this has to be seen very carefully initially that why are we passing the address? At the moment, my suggestion to all of you is that you just don't worry about why are we passing address, but you just understand what happens when you pass address of S. All right, so that's the call to push. We have passed the address of S and we have passed the value of X. But you tell me, do you really remember from the previous video that what S is? Now S has been declared as stack. So S is a variable and S contains only one member called top. And in the next line here, initialization was done. S dot top was made null. So this is S, isn't it? This is S, correct? Now, definitely this S is stored in the memory. So, at what place is this stored in the memory? It will have some address. Imagine address at which this S begins is 100. That means this S variable, the stack variable, has been stored at location 100 in the memory. And what we are doing here, check the line which I am underlining. While calling the push function, we are passing address of S. That means we are passing this address 100 to the push function. Rather, we are not passing S. I repeat, we are not passing S. I repeat, we are passing address of S, and address of S is the location at which S begins or S is stored in the memory. And the second parameter that we have passed, check this, is simply X, the value that we want to push. Keeping this in mind, let us now come to the push function. I hope you have understood the call to push. How was the push function called? Now let's have a look at what push function does and how are the parameters written. Now notice this void push function has two parameters. Obviously, because the push function was called, I repeat here, this is the call written in main and s, correct, comma x. This was the call, isn't it? So if this push is going to be called like this, there are two parameters. So there have to be two parameters here, correct? And check the very first parameter. The very first parameter is the pointer because this pointer p is going to receive what? is going to receive address of S. Yes, and you know that only pointers can receive the address, only pointers can store the address. But which type of address is this? Whose address is this storing? The P stores address of S, and S, remember, is a stack. So the pointer P here declared in the parameter has to be which type of pointer? Stack pointer, and stack itself is a structure. I hope you are understanding. Just check it that we are passing address of S, correct? The first parameter we are passing is address of S. Now, if you are asked what is coming in this push function, you will say address of S is coming. I ask you, no, elaborate. Just explain it further. What do you mean by address of S? You say address of such a variable S, which is a stack. Come on, S is a stack, isn't it? Which contains only one pointer called top. So this S, this S, which you saw in the memory, which stores only top pointer, and assuming that the address at which it begins is 100, we are passing address of this S, which is 100, and that is stored by the pointer P. What that means is there will be a pointer P in the memory now. There was no such pointer before, but this P will literally store 100, and it will point to this location 100. That means P is now pointing to S. P points to the address that it stores address of S. So P points to S. And naturally, the second parameter, as you see, this X is nothing but 10. Now watch that inside this function, we are going to access this top variable by writing P arrow top. Just observe that. See this line, P arrow top. Actually, we can access top by writing S dot top also. Come on, because top is a member of S. But we are going to refer top by using P arrow top notation and not this way. Why? Why are not going to write S dot top? Because hello, if you write S dot top anywhere in this particular function, you will get error S not defined. You know the fundamentals of C language that S has a scope only in main. Please tell me where is S declared? Now S has been declared inside main. Just check main. In the main, we have declared struct stack S. So where can you access this S? See this S can be accessed only inside main, correct? Only in the boundaries of main. So although there is a variable S which has top. This S itself cannot be accessed in another function called push because push is beyond main. Push is outside main function. Then what we did, we passed the address of this variable S and stored it in pointer P. Now P is storing literally the address of S and it is pointing to S. Now we can access this top not by writing S dot top inside push function. Inside push function, we can access this top by writing P arrow top. You will get used to these notations very soon, but now let's see how this push function, we are just 2 minutes away from completion of the operation of this push function. You know what? Push function is hardly 2 to 3 lines long. What is challenging for the beginner is to understand the parameters and why we are writing the parameters in the form of pointers. So where were we? We had S, which had top, and top was null. And we have a pointer P who literally stores address of S. So P points to S. From now onwards, I will stop showing addresses like 100 and then P stores 100. It is understood that if P points to S, it is storing the address of S. Now start reading this void push function. Here we have declared a new pointer. Observe this. Some name I have given, just for fun I have given the name like that. I mean new record. We are creating a new record. So I have declared a pointer. This new rec pointer, correct? This new rec pointer is of node type. So in the memory, there will be a pointer called new rec. This is a pointer created. But right now it is not pointing anywhere. And remember, this new rec can point only to a node because it is declared as a node pointer. Now the next line, I expect that students watching this video knows what is malloc and they have learned all the previous videos. Now this line says that you are going to allocate memory for a new node, isn't it? So a new node will be allocated in the memory which can exactly store integer data and a pointer called next. Come on, because node is a structure which has data and next, isn't it? And this new rec pointer which is written on the left here will point to the new node. What that means is whatever is the address at which the new node is allocated. Let's say that the address at which the new node is allocated is 200. This is the address from where the new node starts. Then new rec will literally store 200. Okay. Now the next statement says new rec arrow data. Check that this is the data field, isn't it? Which I am underlining. And second is the next field. Now new rec arrow data should become X. That means this value should become 10. So what we have done till now is that we have created a new node and we have stored the data in that node. And now check that the next line is a if statement where it says if p arrow top is null, just keep an eye on the diagram. Is p arrow top null? Yes, exactly. P arrow top, check this, is really null, isn't it? So if this is true, then we are going to do new rec arrow next equal to null. Observe this new rec has a next pointer which is made null. So naturally the if was true here, so new rec arrow next became null and else will not run. So this else statement doesn't run, but the next line runs, which is a common line, or rather a line outside the if statement where we have said p arrow top. Check where is p arrow top? Yes, this top we are talking about. Here I am underlining in the S structure equal to new rec. So p arrow top equal to new rec means p arrow top should point wherever new rec points. So p arrow top, listen, p arrow top which was null, isn't it? P arrow top was null, will be no more null, but P arrow top will now point wherever Nurek points. And where is Nurek pointing? Nurek is pointing to this node and top will point to this node. What that means is after this statement P arrow top equal to Nurek, that's the end of the push function. And when push function ends, we go back to main. By the way, some cleanup work will be done. See, when this push function ends, there are some variables which are deleted. The variables that are deleted are the variables that were created during the function. Which variables were created? Observe this new rec was created. So this new rec will be deleted. Node won't be deleted. Hello, node won't be deleted. But that new rec variable which was there in the scope of the push function will be deleted. Also, variable called p was created. That was a pointer. This pointer also will be deleted. Okay, that means we are having a node. Check this fresh. Check this diagram where I have done some garbage collection and some variables have been deleted. Check that we have a node which stores 10 whose next pointer is null, obviously because there is no follower. And we have stack S as earlier, which has top, and top really points to the topmost node. Which is the topmost node now? Of course 10, because there is no other node in the stack. Okay, let's do one more drill on this. Let's do one more revision. What is the stack that we are till now having? Let's see again. The stack that we have till now, it contains only one node, that is 10. And 10 has next, and this next is null. This is the only node that has been created. And we have S, which has a top pointer. And listen, top is no more null. Top now points to this topmost node. Okay. Now let's call push function again. Recall, what are the arguments passed to push function? What are the parameters? Recall the call. The call is pass the address of S. Address of the stack is passed in which we want to push some value. Let's say the value now we want to push is 20. So we want a new node to be created which will store 20. But listen, this P is a pointer. which stores address of S. So again, we at the bottom of the screen I am drawing, again we have this P which stores address of S. I hope you are understanding. Not too many arrows. Don't worry. If you have come from the topic of linked list, I repeat, this might not be very heavy for you if you have watched the videos of how to create singly linked list. I have explained all these parameter passing, why we are passing address and all that. But anyway, repetition is always better. So this P stores address of S. So P points to S. Now onwards, inside this function, I will access this top, which is the member of S, as P arrow top. Okay, keep reading the function with me. There is a new pointer called newrec declared. Remember last time this newrec was erased? So in the memory somewhere there is a pointer called newrec. And this newrec pointer can point to a new node because it is node pointer. Now this line newrec is equal to malloc. What are we allocating? Memory for a node. Check. So again a new node will be created due to malloc. Okay. And this newrec will point to the new node. Because we have said it on the left hand side, newrec should point to newly allocated node. Let us assume that the newly allocated node is stored at some address, let's say 300. Then newrec will be literally 300. Correct? And remember, this node has two members, data and next. Check this next line which I am underlining here. Newrec arrow data should be equal to 20. So this newrec arrow data is 20. That's what we have come here for. We have come here for pushing the new value. Now we have to talk about next. I hope you understand that this next should not be null, but this next should point to, yes, the node which stores 10. This is the association we want. Any other change? Yes, we want top not to point here, but top should point to latest node. I hope you are understanding the changes. So how are we going to do this? Let's see. Let's see. Let me put the diagram in the previous state. Okay. Now this is the new node, isn't it? 20. And we want its next to point to 10. So let's check this if statement. We ask, is P arrow top equal to null? No. Check that P arrow top, this one, at the bottom of the screen, check P arrow top is not null because it is very well pointing to a node. So we will land up in else because if is false. So this else is getting executed. And what is the meaning is newrec arrow next. Where is newrec arrow next? This one which I am underlining. Check this. Newrec arrow next should become equal to, check the statement, newrec arrow next should become equal to P arrow top. And P arrow top is nothing but P arrow top is pointing to this node. So newrec arrow next will point wherever P arrow top points. Where is P arrow top pointing? P arrow top is pointing to 10. So newrec arrow next will also point to 10. Just check this. Top is pointing to 10, isn't it? And newrec, we are saying newrec arrow next should also point wherever top is pointing. That's the statement. Okay, time to erase the screen. Just tell me, what did we do exactly over here? Exactly, we had a node which stored 10. Its next was initially null. And we had S which had top. Top was not null, top was pointing to this node. And we had a pointer called P. This was the parameter which stores address of S. Now coming into this function, we declared a new pointer called newrec, and we asked this newrec to point to a new node, isn't it? By malloc. And then we said, hello, newrec arrow data, this data should be X, which was 20, assuming that user has passed 20. But then we wanted this next pointer of 20 to point to 10. But then who is pointing to 10? Tell me, who is pointing to 10? Top is pointing to 10, isn't it? Top is pointing to 10. So we just tell this next that you better point wherever top is pointing. And that has been done in the else section over here. First we check Is P arrow top equal to null? But that's false because P arrow top is very well pointing to 10. So we will go to else and say numeric arrow next, this next. U should become equal to P arrow top, and P arrow top is exactly pointing to 10. So that's the else section which has got executed. But then there is one more line I am underlining here. P arrow top should be equal to numeric. What that means is P arrow top should point wherever numeric points. Just check this. P arrow top will discontinue to point wherever it is pointing. But we are saying P arrow top should point wherever numeric is pointing. And hello, numeric is pointing to 20. So P arrow top should also point to 20. And that ends the push function. Just check that we have a perfect stack here. First value pushed was 10, second value pushed was 20, and 20 has become topmost. And 20's next is pointing to 10, and 10's next is null. Don't forget, when push function ends, some variables are deleted. The variables that were created by the function. So numeric was created by the function, deleted, and this p, which was a parameter, is deleted. And we have a perfect stack. We have a stack where we have s, correct? S, which has top, and top points to the topmost node which is inserted right now, and the topmost node points to the previous node, and the previous node has next equal to null. All right. So what else can I do over here? I can keep running this push function all day, inserting nodes after nodes after nodes and understanding. Finally, what happens is I just remember this once I keep drawing these diagrams. So how about running this for the final time? What is the stack I am having now? 10's next is null. Well, just now I push 20, whose next is now pointing to 10. And I have S, which has a variable called top, and top is pointing to 20. Now let's call push function third time from main, and we want to push 30 in this stack. Obviously, the first parameter passed is the address of S. So P again stores address of S. So P is a pointer which points to S. Now inside this function, we have declared a newrec pointer. So there is a new pointer called newrec. And what we are doing is asking newrec to point to newly allocated node. So this newrec will point to a new node which can store data and which has pointer called next. The next line says newrec arrow data should be 30. This is the data field which I am now putting as newrec arrow data is 30. Now talk about next. What do you say? Newrec arrow next should point to 20, agreed? Correct. Newrec arrow next should point to 20. I hope you are understanding. But how will you do this? How will you make this newrec arrow next point to 20? You ask in yourselves by checking the picture, who is pointing to 20 in the entire figure? Check this. Who is pointing to 20? Come on, it is visible that top is pointing to 20, isn't it? Watch that. Top is pointing to 20. So how about telling this next pointer that you better point wherever top is pointing? So that is exactly the line written in the else section. Of course, we will go to else because if will be false, because P arrow top equal to null is false. Observe that P arrow top is pointing to 20. So it's not null. So we are going to land in the else. And in the else, we are saying newrec arrow next. Yes, this one. Newrec arrow next. This pointer should point wherever P arrow top points. P arrow, check the bottom of the screen. P arrow top is pointing to 20. So newrec arrow next should also point to 20. That's the else section. But after the else, there is a common line, isn't it? This one, which is out of if else. And we are saying P arrow top should point wherever newrec is pointing. So P arrow top, where is it pointing right now? To 20. It will discontinue to point here. But P arrow top will point wherever newrec is pointing. Observe that the newrec is pointing to 30. So top will now point to 30. That will end the push function. What do you say? That's the last line, isn't it? It will end the push function. And observe that we are having a perfect stack where top of the stack is pointing to 30, 30's next is pointing to 20, 20's next is pointing to 10, and 10's next is null. By the way, you know that newrec will be deleted before you return to main, and p will be deleted. That's the stack that we have created. And as I said, the choice is yours. I mean, the choice is yours. Some people find it funny. I don't mind running this push function on paper like this 10 times. And when I keep reading these statements, ultimately this fits in one of the neurons of my brain. And I never forget. I will never forget the push function if I draw the picture like this from the start of, obviously, since when the stack was empty, top was null, and call the push function first time, then second time, then third time, and how this picture grows. And this is going to explain us how stack is created. In the next video, I will tell you another very interesting operation called pop operation. See you all in the next video. Thank you.